We're going to take a quick look at VLSM here. Now, this is not comprehensive because I have given you videos and a workbook that you can use to work through how to do this. The videos, which are the same set of videos you had back here, only it's videos 29 through 31, are available to you in order to see how to do VLSM subnetting. So I'm not going to make a whole new set of videos for that since I already have them for you. There is also a VLSM workbook that is similar to this workbook that you had back here, only it's on just VLSM. Now these are required, these videos up here. You really need to watch these videos to learn how to do VLSM. The workbook is not required, however it's there. If you like to use the workbook, you can certainly do that. Now remember, these over here are for review of standard subnetting, and then these are for VLSM. Alright, this quick review now, or not quick review, but this quick problem in VLSM. Now I want you to know that I have not done this problem ahead of time. I just made something up off the top of my head, put it here, and we're going to work through it together to see how to do it. So here's the deal. In VLSM, we don't want the same size network. We don't need 64 hosts here, or 62 hosts, in order to get 16 out of this guy here. Right? It wouldn't make any sense. We'd be wasting a lot of addresses. So we want to compact these as much as we can. So here's how I'm going to do it. Now remember, by the way, I'm starting out at a 192.168.0.0/16, which means these first two octets right here are the network octets, and then these two octets are the host octets that I can borrow from. So I can borrow from the third octet. That's perfectly valid to do, and I'm going to need to do that here. So let's take a look at these. The first thing we would do would be to put these in numerical order from largest to smallest. Now I've already done that in this case, but many times in a problem you will not have them in numerical order, and you'll have to put them in numerical order. So 260 usable hosts is the largest one I need. We're always going to start with the largest. So in order to get 260, let me see, the number of hosts, remember, is in this first column here, and 128, well that's not enough. So let's go down to the hosts in the third. 256, that's not enough for 260. 512 certainly is. So my first increment is going to be 512. Now, for the second one, we need 150. So I'm going to look at hosts again. I can get 150 out of 256. I certainly can't get it out of 128, but I can get it out of 256. So the next one is going to be 256 large. The next block that I need is 64. Well, it looks like I could get it out of this, but remember we have to subtract two. One for the network address and then one for the broadcast address. So I can really only get 62 out of this, so I'm going to have to jump to a 128. The last one here I need 16, which is right here, but remember I can only get 14 usable addresses out of that, and I need 16. So I'm going to use the 32 over here. Alright, that gives me everything I need to begin working on this. But what are the actual increments in the individual octets? Remember that the increment is only up here. This only says host down here. It does not say increment. We're going to worry about how to get the increment from up here in this line, and then the octet number from this section down here. So in other words, to get a 512, I need to increment by 2 in the third octet. So 512 is a 2 in the third octet. 2 in the third octet. Alright, 256 is a 1. Here's the 256 down here. 256 is a 1 in the third octet. A 1 in the third octet. Let's do it the same way I did the other one. A 128, that's here, is a 128 in the fourth octet. And then down here, a 32 is a 32 in the fourth octet. Alright, we now know what our increments are going to be. Let's put our network address in here, 192.168.0.0. Now I'm going to increment 2 in the third octet. Alright, let's put that in there. I'm going to increment by 2 in the third octet, which I just did. Now I need to increment by 1 more in the third octet for the next one. Next I need to increment by 128 in the fourth octet. Let's put that in. That was a 3, and then 128 in the fourth octet. Finally, I need to increment by 32 in the fourth octet. Let's see, 32 would be, what, 56? 156? Let's see, 2 plus 3 is 5, and 8 plus 2 is, oh no, that's not right, 160. There we go, 160 in the fourth octet. Alright, so we have those. All we have to do now is get our broadcast addresses. So let's go back here. 192.168.3.1 before 160 would be 159. 1 before 128 would be 127. One before 3.0 would be 2.255. And 1 before 2.0 would be 1.255. Now we can get our last usable addresses. They're simply one less than the broadcast address. Alright, 254 for that one. 168.2.254 for this one. 3.126 for this one. And 3.158 for this one. Now we can get our first usable address 0.0. The next one would be 0.1. 2.0, the next one would be 2.1. 3.0 would be 3.1. And 3.128, the next one would be 3.129. Now all we need is our subnet masks. Well, very simply, we took a 512, so the subnet mask is right here, 254 in the third octet. 255, 255, 254 in the third octet, and 0. For this one, now remember the subnet mask changes for each of these because these are different sizes. So for the 256, that is a 255 in the third octet. For the 128, that's down here, and we have a 128 in the fourth octet. And then finally down here we have, for the 32, we have a 224 in the fourth octet. What did I say? That was 224. Alright, we've got all of those resolved now, and I won't bother to resize these things. We don't need this. That was just for accounting purposes there. And there we have it. By the way, we could put CIDR notation in these if you wish. So this 255, 255, 254, 0 right here is the same as CIDR / 31. 255, 255, 255, 0 is the same as a 32. 255, 255, 255, 128 is the same as a /25. And 255, 255, 255, 224 is the same as a /27. And there we have it. We have done VLSM subnetting. Now you don't have to do it exactly the way I do it. I put a lot of stuff in here to help us out with how to do these, but certainly you can reduce some of these steps if you wish. And eventually, as you get better and better at it, as you do enough of them, you can even do away with a chart altogether and just do it real quickly with a pencil and a piece of paper and just do fine. So there you go. That's VLSM subnetting. A quick example, although for more detail, please see these sources up here.